The opposite of multiplying two binomials is to factor or break down a polynomial. Polynomial just means many-termed expression. So when we factor a number, it means to rewrite it as the product of smaller numbers. So for instance, if we had the number 72 and we wanted to break it down to its prime factors, just like when we're doing the factor tree, right, to simplify radicals, right, we would divide 72 by any number. So for instance, 72 is divisible by 8. 8 divides into 72 9 times. So I could break 72 into 8 and 9. If I multiplied it back together, 8 times 9 still equals 72. I could break down the 8 into 4 and 2. And 4 times 2 is still 8, and 8 times 9 is 72. I could break down the 4 into 2 and 2. And 2 times 2 is 4, 4 times 2 is 8, and 8 times 9 is still 72. I can't break down the 2's any further, because those are prime numbers. We could break the 9 down into 3 and 3. And see if we multiplied them all back together again. 2 times 2 times 2 times 3 times 3, we would still get 72. Right? We've just broken down to its prime factors. Right? Because 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and then 24 times 3 would get you back to 72. So to factor an algebraic expression means to rewrite it as the product of simpler algebraic expressions. We factor algebraic expressions to simplify the expressions and to help solve equations. To factor a trinomial, we need to reverse the multiplication process. Specifically, we will be reversing the distribution process, which is why I had you learn how to multiply by distribution. It is going to look just like multiplying using distribution backwards, because that's really what factoring is. It's the reverse of multiplying. So this is in your notes. All the steps are here. To factor trinomials, we're going to use factor by grouping. It is such a useful tool. You absolutely need to master factor by grouping. Not only will you be able to factor problems like these that we're going to be doing in quadratic expressions that we're going to be doing in Algebra 2, you can also later on use the exact same steps to factor more complicated expressions. Right? And so the product of two binomials results in a four-termed expression that can sometimes be simplified to a trinomial. Right? So we had four terms, and for our quadratics, you notice in every case we were able to combine, right, two of them because they were like terms, just to remind you, right? So here we combined the negative 28x and the negative 28x. Here we combined negative 6x and 16x, and here we combined, that's the same problem, same values. Here we combined 4x and negative 9x. Right? So sometimes we have four terms, but we add the two like ones together, and then we end up with three terms, which is what happens with our quadratic expressions. So we want to get back to the four terms. Right? So to factor the trinomial, we're going to reverse the process using factoring by grouping. So we have to figure out what were the two terms that were there before that we simplified to just get one term. And to find that, we're going to multiply the coefficients of the first term and the last term. Right? So we're going to multiply the a is just the coefficient in front of x squared, and c is the constant term. So in this problem here that we see below, a would be 2, and the constant would be negative 4. We're going to find two integers whose product is ac and whose sum is b. If this is factorable, there'll be some number that multiplies to give us AC and adds to give us B. And B is the coefficient of the x term. For this problem here, it would be the negative 7. We're going to rewrite that middle term, bx, as the sum of the two terms whose coefficients are the integers that we found in step 2. So those integers we found, we're going to replace that middle term and rewrite it as two terms. To do the factor by grouping, the first two are going to be a group, and we're going to put parentheses around them. The second two are going to be a group, and we're going to put parentheses around them. And we're going to factor out a common term from each of the groups. Your goal in factoring is to get a common binomial factor. It will look the same as distributing to multiply. One factor is going to be that repeating factor, and the second factor is going to be the terms being distributed. Now the steps sound much more complicated than they really are. Sometimes it's hard, words are more complicated than actual doing it. So now let's do it, right? And you'll see it's really not difficult. And once you get the hang of it, you'll be very, very quick. All right, so we're going to factor the one that we had on the other page. 2x squared minus 7x minus 4. We multiply the coefficients of the first term and the last terms. All right, so we're going to multiply 2 times negative 4, and that gives us negative 8. So now we need to find two integers whose product is negative 8, but whose sum is negative 7. Well, let's think. What are the factors of negative 8? Well, we've got 2 and 4. No, they're only 2 apart. Right? And we have 8 and 1. Well, they're 7 apart. Right? So one of them is going to be the negative 8. And the other term is going to be the 1. So notice, negative 8 times 1 gives us negative 8. And negative 8 plus 1 gives us negative 7. So that means that before somebody added these terms together, there really was 2x squared plus negative 8x plus x plus negative 4. And then somebody combined the negative 8x and the positive x and got negative 7x. So we're just separating them back again. All right, so then the first two are a group, the second two are a group. By the way, it does not matter if you were to switch those and put the 1 next to the 2 and the negative 8 next to the negative 4. Maybe you like the negative 8 next to the negative 4. You look at it and you go, oh, that looks nice. You know, 8 and 4, they look nice together. 2 and 1 look nice together. It won't make any difference at all which way you place those two terms. You will get the exact same answers. All right, so now we could factor out the greatest common factor here. They're both divisible. 2 and negative 8 are both divisible by 2, and they both have an x. So I can factor out a 2x. 2x squared divided by 2x is x. Negative 8x divided by 2x is negative 4. Notice we have an x and a negative 4, and they don't seem to have anything in common. But everything is divisible by 1. So if they have no common factors, their greatest common factor is 1, which works out very nicely for us anyway, because x divided by 1 is x, and negative 4 divided by 1 is still negative 4. So you see we have a repeating factor, x minus 4. That's one factor. We factored out a 2x plus 1. That's the other, and we're done. And once you get the hang of this, you'll be able to do this in seconds. Let's look at another one. Right? So this one's not in your notes. 1 times negative 24 is negative 24. We need two integers whose, notice it says integers, right? We want integers, whose product is AC, his product is negative 24, and whose sum is B, whose sum is 10. All right, so factors of 24, we've got 3 and 8. Those are 5 apart. And by the way, if I've got a negative as a negative constant, I have to multiply a negative and a positive. So that means I have one negative number and one positive number. Right? So 8 and 3 are not it. They're 5 apart. 4 and 6 sounds promising, right? But let's think about it. All right, so it has to multiply to give me a negative. Right? One of them is going to be negative. Right? Well, now if we look at those, now that's not going to add to 10. Right? So sometimes two numbers look like they're going to be the ones, and then you realize, oh, the signs aren't right. If that was a positive 24, it would have been 4 and 6. We have one more pair of factors. Right? We have a negative 2 and a positive 12. Negative 2 times 12 gives us negative 24. Negative 2 plus 12 gives us 10. All right, so now let's replace that 10x with a negative 2x and a positive 12x. Notice you don't do anything to the first and the last term. It's just the middle term because it used to be 4 terms. The first two are a group. The second two are a group. I can factor out their greatest common factor is an x, right? That's what they have in common. If I divide x squared by x, I get x. If I divide negative 2x by x, I get negative 2. 12x and negative 24, their greatest common factor is 12. They're both divisible by 12. 12x divided by 12 is x. Negative 24 divided by 12 is negative 2. You have to get the same thing in the parentheses. If not, although it's interesting, I wrote my 2's differently. If not, then maybe you made a mistake. Maybe you chose the wrong numbers. Maybe you have a division error, right? You can always ask me if it's not making sense. All right, so x plus 12 is what we pulled out, and we have the repeating x minus 2. It does not matter the order you write those, all right? It doesn't matter if I write x minus 2, and then I write x plus 12, or x plus 12, and then x minus 2. Multiplication is what's called commutative, which means that the order doesn't matter. Let's do another one. All right, so here we're going to, we have, and I didn't do this on the other pages, shame on me. I should have identified the A, B, and C. Always a good idea. So, and we had this identified on the other page, which is probably why I forgot on the second one. Right, so on the other page we had A was 2, B was -7, and C was -4. Right? So A is the coefficient in front of x squared, B is the coefficient in front of x, and C is the constant term. Right, so in this problem, A is the coefficient in front of x squared is 1, the coefficient in front of x is 10, and the constant is -24. This time I actually put an A, B, and a C for us. The A, the coefficient in front of x squared is 3, B, the coefficient in front of x is 10, and the constant is -8. We multiply A times C, so 3 times -8 is -24. I think I've seen this before. Multiplies to give me -24, adds to give me 10. I think it might be -2 and 12. So interestingly, the same set of numbers for a different problem. And we're not going to get the same factors because this is a different problem. But that is we did have the exact same middle terms, -2x and the +12x. All right, so we're just getting back to what the two terms were before they were combined to create the positive 10x. The first two are a group. Like I said, the order doesn't matter. Right? So I just put the -2x first, and I put the 12x second. First two are a group. The second two are a group. From the 3x squared and the -2x, we can factor out an x. We're going to be left with a 3x and a -2. And from the 12x and the -8, they're both divisible by 4. 12x divided by 4 is 3x. -8 divided by 4 is a -2. Right, so we've got that repeating, 3x minus 2. And what we pulled out, x plus 4. And I could have written the x plus 4 first, and then the 3x minus 2, and it wouldn't matter. Right? So you see the steps are just very, very repetitive. And that's what makes this easy, because once you get the hang of it, then you're just doing the same steps over and over again. This time I'm going to remember to write A, B, and C. So A is 3, B is -4, and C is -15. So 3 times -15 gives us a -45. Somehow I got lost when I was typing that one. So we need two integers whose product is -45, but whose sum is B, whose sum is -4. Well, 45 doesn't have many factors. It's got 3 and 15. Well, they're too far apart. They're 12 apart. It's got 1 and 45. They're a lot apart. And it's got 9 and 5. And 9 and 5 are indeed 4 apart. All right? So let's use the 5 and that -9. They multiply to give us -45. They're going to add to give us -4. If you've got a negative product, one of the numbers has got to be negative. All right? So 3x squared, we're going to replace that -4x with a positive 5x and a -9x. And you know, I kind of like, even though it doesn't matter, don't they look nice together, the -9 and the positive 5? It just looks good together that way. It doesn't matter, though, if I have it the other way. The first two are a group. The second two are a group. What can we factor out of 3x squared and -9x? We can factor out a 3x. 3x squared divided by 3x give us an x. -9x divided by 3x would give us 3. Right? And what could we factor out of 5x and -15? Well, that would be a 5. 5x divided by 5 is x. Negative 15 divided by 5 is a negative 3. So that repeating, I lost a negative there. It's negative 9x divided by 3x, that's negative 3. All right, so if they don't match, take a look. Here I had a division error, I lost my negative. All right, so that repeating x minus 3 is one factor, and what we pulled out, the 3x plus 5, is the other factor. And I would have gotten the same answer if I put the 5 here. And you can see the only thing I wouldn't be able to pull out was an x if I put 5 here. And that still would have given me the 3x plus 5. All right, so the order you put those middle terms in doesn't matter. I sometimes like to put them next to one another if they, I see they have common factors. All right, so let's try this one. 2x squared minus 19x plus 24. Our a is 2, our b is negative 19, and our c is 24. We're going to multiply the coefficients from the first and last terms. All right, so 2 times 24 is going to give us 48. We need two numbers that multiply to give us a positive 48, but add to give us a negative 19. Well, if they multiply to give us a positive number, it means they're both positive, they're both negative. But if they add and give us a negative number, they're both negative. All right? So what's going to add to negative 19? Well, factors of 48 are, we got 12 and 4, but they don't add to 19. We have 24 and 2, but they don't add to 19. And we have 3 and 16. They add to 19. So we have a negative 3 and a negative 16. All right, so we're going to rewrite that middle term, rewrite that negative 19x as a negative 3x and a negative 16x. All right, and what can we pull out of 2x squared and, oops, we lost the parentheses there. 2x squared and negative 3x, well, all they have in common is an x. All right, divide 2x squared by x, you get 2x. Divide negative 3x by x, you get negative 3. Negative 16x and 24, greatest common factor, it's going to be a negative 8. Make sure you pull the negative out because we want that first term to be positive. We want a positive 2x, not a negative 2x. So we're going to factor out a negative 8. Negative 16x divided by negative 8 is going to give us a positive 2x. And 24 divided by negative 8 is going to give us a negative 3. So there we have our repeating 2x minus 3. They match. And then what we pulled out was the x minus 8. And there we go, all factored. 5x squared minus 21x plus 4. There's a whole bunch that weren't in your notes. Finally, there's one in your notes. The a is 5. B is negative 21. Look at my poor negative. And c is 4. And so 5 times 4 gives us 20. We need two numbers that multiply to give us 20 and add to give us negative 21. Right? So they're added to a negative number. They're both got to be negative. And I hope you figured it out. It's going to be negative 20 and negative 1. I hope that one was an easy one. All right, so we're going to replace that negative 20x with a negative 20 and a negative 1x. Right, and first two are a group, second two are a group, so we'll put our parentheses around them. What can we factor out of 5x squared and negative 20x? They're both divisible by 5x. 5x squared divided by 5x is an x. Negative 20x divided by 5x is negative 4. All right, now be careful. Don't just pull out a 1 here, right? Because the signs won't match. We need to pull out a negative 1. We want what's in the parentheses to match. Negative x divided by negative 1 is a positive x. 4 divided by negative 1 is a negative 4. Now we have a repeating binomial, x minus 4. And what we pulled out was 5x minus 1. And there we go. All factored. Lickety split. All right, so factors that equal a negative number, if your last term in a trinomial expression is negative, one of the factors has to be positive and one of the factors has to be negative. Factors that equal a positive number. If our last term is positive, the factors in the last position are either both positive or both negative. To determine if the numbers are both positive or both negative, it's the middle term. If it's positive, they're both positive because they added to a positive number. If it's negative, they're both negative because it added to a negative number. And I'm at 20 minutes. And so I'm going to, I think, split this into 2 podcasts and continue on with factoring. Bye for now.